Hello everyone, welcome to part 2 of my series on how to create a tag bot in Node.js using Discord.js. Today we're going to be moving away from the Discord side for a little bit, and we're going to be working on the main feature of our bot, which is the custom programming language. So users will be able to write their own little commands that can be run through your bot. So we're going to go to Atom, and we're going to first need to create some new files. So the first file is going to be called grammar.ohm, and the second file is going to be called, we'll just call it language.js. Okay, so for this episode we're going to need to install a couple more dependencies. So first we're going to back to the terminal. So we have to go back to the terminal, and we're going to type npm install save ohm-js and Lodash. Lodash is utilities, and ohm is you might recognize it from when we created grammar.ohm, and that's just the package for creating the custom languages. So we're going to switch back to Atom, and we're going to go language. So first we're just going to have to type this out to load ohm, and then now we're also going to need to load Lodash. So the convention is just to require Lodash as underscore, so we'll just use the typical way of doing it. So we'll do it like that. We'll change these to double quotes. So the first thing we want to do is, so now that we have those set up, we want to go to the grammar file. In grammar, we're going to call this grammar language, and then we do brackets. So what's our language going to look like? A program in our language is going to be one or more lines. So the plus is one or more. A line is a statement, and then either semicolon, it can be a new line, or it can be the end. So now we want to define what each of these things are. So a line is a statement. For now, we need to statement definition. We're going to do that next. First we need to define what end is. So end in our language is just the end of the input. So that's already set up for us. Semicolon means that a line is a statement and then a semicolon, or it can be a statement and then a new line. So a line could look like this. Something, some statement, some statement. It could look like this. It could look like this, or anything like that, basically. So now that we have that, we need to set up what a statement is. A statement in our new language is the first one we're just going to have is the first statement that we can have in our language is a so is to set an identifier to an expression. So now we need to define what an identifier is in our language. An identifier is not a keyword. This is the not symbol in ohm. So not a keyword, and then it has to start with a letter, and then this part means we can have alphanumeric, so A to Z, capital A to Z in lowercase, and then also numbers, so alphanumeric, and it can also, or it could be, this is or it could be an underscore, and we have 0 or more of those, which is this asterisk. So now we need to define what an expression is. So setting up expressions in ohm is kind of weird because we have this weird kind of cascading thing for order of operation. So we're first going to want to set we're going to have an OR operator, which is or an AND expression, and we need to put this at the end. It says this, dash dash or, and this is going to help us later. We also need this one to be called assignment. Or this can be called an expression, and we're just going to call this one last. So this part is basically just the, this needs to be and expression. This part here is just like the name of the thing, and that's going to come in later when we are programming how our language should be run. So now that we have the or expression, expressions are just going to become or expressions. Like that. Okay, so now we're saying an or expression can be something or something, so this is going to be Boolean or, like true or false or true or something like that. So then we have and expressions. An and expression equals an and expression and comparison expression. I'm probably not doing a very good job of explaining this, but it's kind of complicated, but it works. So we have this, now we can do comparisons. So a comparison in our language is equal to a math addition expression less than or equal to a math addition expression, and we're going to call this one LTE for less than or equal to. Now we're going to just copy paste this a bit, and we're going to change these to the pipe character. So now we can do add less than, we can do equal to, not equal to, less than or greater than or equal to, and greater than. So now we want to change the names of these. So this is less than or equal to, less than, equal, not equal, greater than or equal, and greater than. Or it can just be a math add expression. Next, we want to define what a math add expression is. And a math add expression is a math add expression plus a math multiply expression. We'll call this one plus, and a math add expression minus a math multiply expression. And we'll call this one minus. Or it can be a math multiply expression. There's only a couple more of them now. Now we have math multiply expression. It's equal to a math multiply expression multiplied by a math exponent expression. We'll call this one times math multiply expression divided by a math exponent expression. This one's going to be divide. The reason why multiply and divide are both called a math multiply expression is because they're the same in the order of operations. And they're just read left to right. It's not like you do multiplication first and then division. Now, a math exponent expression is equal to a math exponent expression to the power of a prefix expression. And this is going to be called power. Or it can be a prefix expression. Then we have prefix expression. And prefix expression can be function call. This is a call. Call. It can be parentheses. So a parentheses is an expression wrapped in parentheses. So the farther down the list we go is the higher priority. So function calls and expressions and those expressions in parentheses, those will be first. Then we'll check exponents, then multiply and divide, then add and subtract, then comparisons, then and, then or. So there's some other prefix expressions that we should add. We're going to just have the constant true. This is called true. we have constant false. False. It can also be just a number. Number. Or it can be an identifier, which is a variable. So now we want to define what a number is in our language. A number is a digit, 0 or more digits, point, 1 or more digits, so this is for decimals. Or it can be just 1 or more digits for whole numbers or integers. So we'll call that integer. So now we have all our order of operations set up. So now we can move back over to language and start programming the actual language. So what we're going to do first is we're going to create an asynchronous function called run. This is going to run a set of code. And now that we have, okay, so the code will just be a string, so some text. We're going to create a semantics object, which is grammar.creates, okay, wait, no, we need to do the grammar first. Okay, we're going to say that the grammar is ohm.grammar text. Okay, we need to also require file system. Okay. So this is file system, fs, so we're going to do const. So this is going to be the text of our file. We're going to load it, read file sync. This is going to be /grammar.ohm. Now we can create the grammar object using ohm by using the text that we loaded. So now if we come back here, we can use the semantics. So semantics is Ohm's way of, you can define different operations that you can do. So this is just, we do create semantics, and that's all that has to do. Now we'll add an operation to our semantics object, which is going to be called interpret. So any program in our language can be interpreted, any part of our language in here, so comparison, and, or, statement, line, program, all of those can be interpreted with the interpret operation here. So the first thing we need to do now, we're going to set up program. So to interpret a program, what we're just going to do is, it's a function of statements. So our outputs for this program, the outputs that this program has, is going to be statements.interpret. So what we're going to do is we get the statements that are in this program. So a program is a set of lines, right? A program is a set of lines. So then from our set of lines, we want to interpret all those lines. And to do that, we need to do some kind of hacky stuff. So we're going to do _iter is an async function of elements. So we're going to set our output is an array. We need to copy in a little helper that I use. So asynchronous function async for each set array callback for index. So what this is just going to do is it's going to, in order, you give it an array here, you give it an array, and what it's going to do is it's going to go through every element of the array, and it's going to call the callback with each element of the array in order, and it'll wait for the callback to finish. So now over here we can do await callback. No, wrong part. Wait. We need to go back down to here. What we do is we're going to await async for each with our list of elements. and we're going to give it a callback, which is function of each element. So to the output, we're going to push await e.interpret. So what this is going to do is when we have a set of like if we use plus or star or something like that, if we have a set of lines, for example, and we call that set of lines, which is statements here, interpret, that will, what it'll do is it'll go through each one in the set, it'll interpret it, it'll add it to the output, and then we will return the output. So it'll basically just interpret each of them in order. So now that we have the outputs from running our program, we're just going to return the last output, which is outputs.length -1. So now we have the basics of our grammar set up, and in the next episode, we're going to start implementing each of the little bits of our language. Thanks for watching part 2 of this series on making a Discord bot with a custom programming language that your users can use. In this episode, we've created this grammar, and in the grammar, we've defined the basic features of our language, and we started setting up the processing for actually running the language. In the next episode, we're going to be going over adding the rest of the operations to this and adding some other smaller features to the language. So thanks for watching, and I'll see you in the third part of the series.